Hello, welcome to the second video for formulas and names. We're going to look at writing formulas and names in this video for compounds that contain polyatomic ions. We're going to look at writing formulas and names for binary covalent compounds and also how compounds are named that have added water. Here's an example of that. Let's start by looking at compounds with complex ions. All right, what does that mean? There's this thing called a polyatomic ion. Poly meaning many. A polyatomic ion is going to be a positively or negatively charged, covalently bonded group of atoms. You know, because it's an ion, it's going to have a positive or negative charge. An ion's a charged particle. You know that it's going to be polyatomic, meaning more than just one type of atom. And they're going to be covalently bonded together in a group. Here's some examples of those. Some common polyatomic ions would be ammonium is one. It's a nitrogen with 4 hydrogens bonded together in a group. And we think of a polyatomic ion in terms of being one unit together. They go around with a +1 charge total, these 5 atoms, and they remain together and intact, and we think of them as one unit together. Here are some polyatomic ions that have a -1 charge. You can see the minus charge for each of those. Here's some polyatomic ions that have a -2 charge, carbonate and sulfate. Again, they are thought of together as a single group, a single unit. Phosphate has a -3 charge. So how do we write formulas and name compounds that have these polyatomic ions in them? I just copied the little chart down so we could see that off to the right. It's really easy to name these and to write their formulas. We just follow the rules, basically, for binary compounds. There's only one extra thing that I want to note about them. If there is more than one of these polyatomic ions that is needed to balance the charge in our formula, we're going to need to place parentheses around it before we add its subscript. And let's look at an example so that you know what I'm talking about. Let's write the formula for barium nitrate. Maybe you'd like to pause the video, try this one on your own and see if you get it right. Remember our rules for naming binary ionic compounds. Let's start with the positive ion first. Barium, it's a metal. It's in the alkaline earth family, has 2 valence electrons. Here's the symbol for it. Barium is going to have a +2 charge. Next, I name the negative ion, and in this case, it's a polyatomic ion, nitrate. You're not going to find nitrate on the periodic table because nitrate is a polyatomic ion. It contains nitrogen and 3 oxygens, and it has a -1 charge. It's right here on my table, so I can copy that down from the table. The whole thing, NO3, and again, it's a capital O because it's an oxygen. So nitrate is 1 unit together. The whole thing has a -1 charge. So next, I need to find the ratio that these individual atoms need to be combined in to form a neutral ionic compound. You can see that I'm going to need 2 of these nitrates because they each have a -1 charge in order to balance the charge with the +2 barium ion. Now in our final writing of this formula, we don't need to include these charges. Those were just there to help us think about this and think about the ratios that we were going to need to write down. So how do we name compounds that have polyatomic ions in them? That's even easier. We simply, 1, write the name of the positive ion, and then 2, write the name of the negative ion. So what's the name of this? Well, let's start with the positive ion. It's going to be potassium, so we'll write that down. Next, what's the name of the negative ion? Wow, that's not on the periodic table. That's a polyatomic ion. As a matter of fact, it's right there on the table. And its name is phosphate, and we simply write it down. That is potassium phosphate. So, how do we name and write formulas of binary covalent compounds? Remember, these are compounds that share. We don't have ions involved. We have sharing of electrons. Now, for binary covalent compounds, we are going to use prefixes. That's the really key thing you need to remember about these kinds of compounds. They use prefixes, and they're all written right here in this chart. If I have one of some kind of atom, I'm going to use a prefix mono. If I have two, it will be di. 3 atoms, tri will be my prefix. 4 atoms, tetra, and we have penta, hexa, hepta. Oops, that's a typo. It should be hepta, and then we have octa. How does this work? Well, to write the formula, the number of each atom is given by the prefixes in the name. If there's only one atom of the very first element, then the prefix mono is going to be omitted, only for the first element. So let's look at an example to help you understand what I'm talking about. Write the formula for dinitrogen monoxide, right there. Well, dinitrogen means I'm going to have 2 nitrogens. I write the symbol for nitrogen with a subscript 2. Monoxide means there will be only one oxide, only one oxygen. That is how I write the formula for dinitrogen monoxide. Now, how do we come up with our own names for these? It's just the reverse. We use the prefixes to indicate the number of atoms of each element. And remember to omit mono if there is only one of the first element. Let's try an example. What is the name of this compound? Well, there is only one nitrogen, and it's the first element. So I'm just going to say nitrogen. I can also see that I have 2 oxygens, so I need to use the di prefix, and I'm going to call it nitrogen dioxide. I add the IDE ending just like I did. I use the base for my oxygen, ox, and I add the IDE ending just like we did for the binary ionic compounds. So what about compounds with added water? Well, let's talk about hydrates. A hydrate is a compound with water that is chemically attached to its atoms. The formula for water is actually written right into its chemical formula, and it's written like this. Here's an example. This is calcium sulfate, our polyatomic ion, and I'm not done with the name yet. It's calcium sulfate dihydrate, because for every calcium sulfate molecule, 2 water molecules are attached to it. It is written with a dot in between, so we write the first part of the chemical formula, we write a dot, and then we write down in a large number, a big coefficient number, how many water molecules will be attached to each one of those molecules. And we use the prefixes that we used for our covalent compounds, and we use that prefix and call it a hydrate. So this is calcium sulfate dihydrate. It is otherwise known as gypsum, a main ingredient in plaster of Paris. Can you figure out what this name would be? It would be called cobalt-2 chloride hexahydrate. That's a big long mouthful. What if we dehydrated this material and took all the water out, which you actually can do? You can heat this up right over here. This part is the cobalt-2 chloride hexahydrate. If you heat that up, you can evaporate that water off of it, and it turns into these nice blue crystals. They are called anhydrous, or without water, and their formula would simply look like this, cobalt-2 chloride. This reaction will happen very fast in reverse. As soon as water combines with this, it will turn pink again, even just water in the air and in the atmosphere. How about some advanced ideas? Look at some different containers and look at the ingredients label and see if you can find 5 different chemical formulas or chemical names. See if you can determine the oxidation numbers of the various elements or polyatomic ions. Here's an example, sodium phosphate. You now know what that would look like in a chemical formula, not just reading this off of a label. What are the oxidation states of sodium and of phosphate? Or we could find the formulas, names, or charges of some of these following polyatomic ions, ones that we didn't talk about. Maybe you have some other ideas. I look forward to seeing what you come up with, and we'll see you in class.